In today's video, I want to show you how I solved the Advent of Code 2021 day 14. This puzzle involves rewriting a string given a set of rules and then counting the occurrences of the different letters in this final string. So in this example, we start with the string N and C, and then each pair in that string is rewritten by inserting a character in between them. So the NN pair, a C character is inserted between them, and the NC pair, a B character is inserted between them. So after one iteration of this starting string, we get the string NC, NBC. And this process goes on and on for a couple of iterations, and we end up with a very large string. But in this problem, we don't have to generate the actual string, we just have to count the occurrences of the letters and then make calculations on the occurrences to get the final answer. So we can read the first line, and that will be the pattern. So pattern is read line and strip any space. Then we skip one line, and then the other things are the rules. So for a line in the file, just want to do so the first one, the first character in the pair is line 0, the second one is 1, and the result is, so let's see, 0, 1, 2, 3, 4, 5, 6. 6. So let's see, let's just print this, let's see what we get. Yeah, looks C and C, the last one, and N and CB. Yeah, so that looks correct. So now I want to say the rewriting rules in a table. So let's call it and then say if X not in rewrite table, then rewrite table X is a new dictionary, and then rewrite table X, Y is C. Something like that. And now we have our table. Rewrite table. Looks like it might be correct. So CH is turning to B. So CH is turning to B. Yeah. So that looks correct. So now we have the pattern. And we have the table, and this will then later also work for the real input, which is a longer starting string and many more rewriting rules. So if we have a look at the picture that I drew earlier, we are only concerned with counting. And the count is kind of recursive based on a pair. So let's try to write a function to count occurrences occurring between a pair. So let's call it count insertions. It will take the left character and the right character and then a level, how many times we wanna, how many levels deep we wanna go. And this should return a count. So I also want to have a class for maintaining counts. So let's call it counter, and let's have it be a subclass of dictionary. And with the counter we can do add, name. So if name not in self, then self name is 1. Otherwise, self name is incremented. Something like that. So this one should just return some counter. So we call print count insertions and then something. Let's see what we get back. So we get back an empty dictionary. That's all right. So this is actually the base case. So if level is 0, this is what should happen. We should return this counter. Otherwise, the character to count is, we want to make a counter and then call add on the rewrite table left right. So this is the character we insert. So let's extract the two variables, say inserted stat. Let's see, so counter, let's make this a variable instead, and then we can return counter, and here we can do counter add, and down here we can just do like that. So if level is larger than 0. Yeah. And then also we need to make recursive call. So now we have inserted, if we look at the picture, we have inserted the C here between the two ends. But then for the next level, for level 2, we have the question marks there. And that's really for the pair NC. It's the first question mark, and the second one is CN. So we need to do call count insertions with the left character being left, and the new inserted, and then decrement level. And we need to also do the other side, which is the inserted and then the right character. And then we need to do counter.merge. The results from that one. And merge just does this. Other, so for name count in other items, self add name count, and we also need to do the count here, which defaults to 1. Something something like that. Okay, so now in this table, so let's do NN and see what that, if we run this now, it should, if we do it for level 1, it should probably fail because A does not exist in the rewrite table. So let's do the example here of NN. NN should be, so C should be inserted. So we should get back from this function a C of count 1. Right. And if we do one other level, C occurs 2 times and B 1 time. That might be correct, we don't know. Let's have the previous character set to none, and then we'll loop over all the characters in pattern, and if previous is not none, then we do count insertions, the previous and the character, and then at a level, I think 10 was given. And then we need to merge this. Then we need to create an initial counter. So we merge all the pairs. And then here we need to set previous to character. And we also need to do counter, counter.merge. We need to count this character as well. So at level 0, we're not counting anything yet, so we need to count this character as well. And that is just counter.add character. So let's see what that gives us. So we have counted that there are 865 N's and 297 C's and so on. So what we need to do then is to print the counter.values, the max value minus the min value. Let's see, 1588. And I think that's the correct answer. Let's see. Yeah, 1588, 1749, 161. Yeah. Now, the only thing we need to do is to run it on the real input. And we get 2797 back. And I believe this is also correct. 2797. The next part of the puzzle is to do this insertions 40 times instead of 10. And this is probably not going to work. I haven't waited that long to see what happens. But it just takes a very long time. So I want to show you how to solve that. So let's go back to 10. And the idea here is to use a cache for the count insertions function. So probably the string that we are generating contains a lot of substrings which are exactly the same. And we can use a cache saying, like, if we see a left character and a right character at the specific level. We only need to do that calculation once, and then we can save it in the cache. So let's do a count cache. And here we say the key is a tuple with left, right, and level. Oops. And count cache key is this counter. And at the very top we do if key in count cache, then we just return that. And we of course have to do the key up here. So let's see if we get the same result, 2797. If I can type, same result. So now that we have the caching, let's go back and make this 40. And boom, we've got something. 2932, is that correct? 2932. That's correct. So yeah, that's it. Thank you so much for watching. If you like this video, please give it a thumbs up, and I'll see you next week.